What is the ratio of 8 feet to 24 inches? All right, so this example, we are comparing two values. That's what a ratio is. It's a comparison usually of two like unit values. So we've got multiple ways we can write ratios, but let's talk about a few of the ratios that you may encounter. So you can have something like an air to fuel ratio. So an air to fuel ratio, the common or maybe the most efficient air to fuel ratio would be a 12-to-1 fuel ratio. That means 12 parts air to 1 part fuel. So there's a ratio that we have. We have something you're going to see is a glide ratio. The glide ratio is equal to the distance forward divided by the altitude drop. So in this ratio, what we have is if your aircraft loses engine power, it will still glide forward. So a common ratio, glide ratio would be 9. So 9 for like a Cessna type, meaning that it's going to go 9 feet forward for every 1 foot in altitude drop again. So we're comparing two like unit values. The larger the glide ratio, the further it will glide for how high you are in the air. We have a gear ratio. The gear ratio is comparing teeth of a gear, two gears that are meshed together. It's comparing basically the size of them. So instead of comparing diameters like we would with a pulley with gears, we can just compare the amount of teeth they have because that's going to be proportional to their size. So we'd have driven gear over the drive gears, number of teeth, and it's basically a size comparison between these two. And we'll compare this gear ratio to a speed ratio is often done. So if we know the gear ratio and we know the speed of one of the gears, we can find the speed of the other gear. So again, whenever I'm doing this, these two ratios, so this is a ratio and this is a ratio. When we compare two ratios together, that's called a proportion. And these two this proportionality is an inverse relationship, meaning as one of them goes up, the other will go down. So this one, the speed of the drive gear will go over to here. This will have the drive RPM, and the driven will then be on this side, driven RPM. All right, so we'll discuss that at some point as well. We could have an aspect ratio. An aspect ratio is looking at how comparing the wing tip, the length from wingtip to wingtip length over the chord length. So if I have an airplane, and it's going to be a crudely drawn airplane, but here we go. So this distance, wingtip to wingtip, is going to be on the top. That will be what's up here. And then the chord. So the chord, if I look at the wing from profile side view, we have our leading edge and our trailing edge. That's what these two things. There's an imaginary line that goes in between the leading edge and the trailing edge, and that's the chord. So what we're comparing is wingtip to the chord. That will give us some characteristics of how that airplane is going to behave in flight. There's all kinds of other ratios you could run into. You could run into when you're mixing composites. You could have a catalyst to the resin ratio, and you'll have to mix like an ounce of this with 20 ounces of resin, an ounce of catalyst, whatever it tells you to mix it with. But there's ratios all over the place, so perfect. All right, we're also going to be able to see usually ratios are written in 3 ways. You can do colon. So an example would be a 15-to-1. If this was an air ratio, it would be 15 parts air to 1 part fuel. So we said the perfect air to fuel ratio was 12 to 1. So that means there's 12 parts of air to 1 part of fuel. In this case, there's 15 parts of air to 1 part of fuel. This would be considered a lean mixture because there's less fuel than there is air compared to the most efficient air to fuel ratio. You can have a fraction. So a fraction could be like our gear ratio. I'm comparing 25 teeth to 10 teeth. All right, we can also just write it as only a number. So in this case, if we had a glide ratio, it tells you your glide ratio is 9. That means I'm going to go forward 9 feet for every 1 foot drop. So those are just some of the ratios that you can run into. But in this case, we have a very simple ratio. It's just 8 feet to 24 inches. So we need to convert one of these units to the other unit. So let's go with 24 inches. We'll just convert it to feet. It would not matter if you went the other way, but we'll just do this way. So we have 24 inches. So we need to know the conversion factor. We know that 1 foot equals 12 inches. We have to decide what number is going to go on the bottom of these two here. Because we want to get rid of inches, we need to put inches on the bottom. So we got 12 inches over 1 foot. So inches and inches cancel. I'm left with only feet. So 24 divided by, multiply across here, multiply across this way, and then divide. 24 divided by 12 is 2. By convention, usually the number they're going to, or often the number they give you first, just put it first. So it would be 8 to 2 ratio, which will reduce to a 4 to 1 ratio. So that would be the answer here. Would it have mattered if I converted the other way, 8 feet to 24 inches? It would not have mattered. It would have come out to the same answer.